Good day everyone, my name is Anditya Arifianto. I'm from Artificial Intelligence Laboratory of Telkom University, Indonesia. And I'll use this opportunity to present one of our research titled Disguising Text as an Image Using Generative Adversarial Network. I'm sure everyone has already an idea of what this is about. So first, I'm going to talk about securing messages. In this Internet of Things era, everyone and everything is connected. So, it's obvious that there's a need of securing ourselves in the digital world. Nowadays, there are many techniques for securing digital data, like using cryptography, steganography, blockchain, and others. And to this day, we have always tried to improve and develop new methods and techniques for securing digital data. Now, I will switch to Generative Adversarial Network. As you already know, standard Generative Adversarial Network consists of two networks. First, a generator network, which receives an input vector and transforms it into a three-dimensional output, which we can form it as an image. And then the discriminator network that receives input image and determine whether the image is a real image or not. The two networks are trained together in a two-player game scheme where they try to beat each other. Generator is trained to be able to produce new generated images that cannot be distinguished from the original images by the discriminator, while the discriminator is trained to be able to recognize which images are real and which are produced by generator. After the networks are trained, usually in most cases, we then only use the generator to perform some tasks. Something like drawing artistic pictures, transforming objects inside an image. We can also use it to generate a super resolution of an image, and even generate a realistic photographic face of a person that does not even exist. Then, what is the connection with data security? Well, we know that it is very common these days to communicate by sending images. So, it's obvious that there must be an idea to use images to hide messages, which we all know is a technique called steganography. It is a common technique. However, the problem with traditional steganography is that the techniques are usually deterministic. These deterministic methods can be detected by the counter techniques called steganalysis. It can be detected by analyzing the anomaly of its pixel distribution or using signal processing to check whether the image has been tampered. And so we come to our research question: can we create such an image with a hidden message inside it that cannot be detected? And also how to utilize deep learning techniques and use it to perform something like steganography. This is an area of research that has not been broadly addressed. The idea here comes from a research called CycleGAN. CycleGAN generates an image translation which transforms one image to another. Like this example, it transforms zebras in the image into horses. Now, if we take a closer look to the generator, it's shaped like an autoencoder. Both the input and output are images. That's why it's called image-to-image translation. Now in our case, we tried to switch the generator. So now it receives and outputs a vector. Then the networks are trained jointly end-to-end. Generator B transforms an input vector into an image, and the discriminator will decide if the image is real or not. Along with that, generator A converts the image back into vector. Now, if we connect this to the idea of cybersecurity, we know that cryptography transforms a readable message into an unreadable one. However, sending a strange gibberish message makes it suspicious and recognizable that something is hidden, while steganography hides a message into a readable cover but does not transform the message itself. Now, if we are using this generative technique, we can say that we are combining both cryptography and steganography. Since, like cryptography, we are transforming the real message, but unlike cryptography, we transform it into a readable and sensible image cover that is not suspicious to send. We suspect that the resulted image is more robust to traditional steganalysis detection since we are not tampering an already existing image. The image is generated from scratch, so it will look more natural and there is no anomaly in the pixel distribution. And so this is our proposed framework. We can take a text input and convert it into vector using a word embedding model, then feed it into generator to produce the image of the input text. These images are then sent to the recipient, which later can extract the message vector using the second generator. In our observations, we train a small generator model using the MNIST image dataset and word-to-vec embedding model that is trained using English corpus. And here, we evaluate the reversibility of the generator model only on 1,000 most common English words. And these are the results. With 0.1 noise generation range, we can achieve 98.9% accuracy of reversible messages. Here is the close-up. If we use exact generator without noise, the second generator can read it with 100% accuracy. But if we add some noise to the generator, you can see here that the image produced from the same word has a slight variation. Thus, makes it harder to detect or recognize by an unauthorized person since it cannot be mapped. Higher noise generation produces more varied images, but it became much more harder to reverse. Although there are still some images that are misidentified. However, since we are using word-to-vec embedding, the misrecognized images are not too far from the original input text. For example here, the original message is mother, but it's recognized as daughter. Another one is nation, recognized as country. To test the results, we perform some attack experiments. Here, we try to perform several resize, rotation, and noise attack to see if the image is still recognizable. The results showed that this technique is quite robust to those minor image processing, which resulting above 90% accuracy. Even with combined attack, it still achieves above 85% of reversibility. However, up to this point, we are only able to produce one image for one input word. And sending multiple images to form a sentence must be suspicious. For that, we try to generate the message as an interpolating GIF animation. And our system can read automatically where the messages are with high accuracy. And so we arrived at our conclusions. We presented a novel implementation to generate an encryption system from text to image which combine both aspects of cryptography and steganography to at once protect and hide the original message. By training the networks end-to-end, our encrypt and decrypt generator was able to produce a unique yet varied generated images for each word with 98% reversibility. We also showed that our system is robust to various attacks with over 86% accuracy for information extraction. With the addition of sending interpolation of generated images as an animation, the encrypted messages can hold longer text payload. Further improvements may include the introduction of private and public key, larger image input, the use of sequence model, new architecture observation, and style transfer mechanism. And that is the end of my presentation. Thank you for watching. If you have any questions, don't hesitate to contact us.